Hey everyone. I just wanted to give a little walkthrough with how this game is set up and how it's built, and let you guys see sort of how something like this comes together. I mean, I know it's still very rough, and all the graphics are still very temporary, and everything is temporary, but at least it gives you an idea of how a game like this could be built. So, just to show again how the game works, you have this dragon and you fly around, and the objective is to try to destroy the entire village and kill all the inhabitants, the citizens. If you're moving, you can just swipe in any direction and it changes to that direction, but you can't swipe and just do a 180. If you try to swipe backwards, then it'll actually just slow you down for a little bit. So you can use this as like a handbrake or an air brake. And similarly, if you swipe in the direction that you're moving, you'll do a little dash. Good for getting out of the way of enemy fireballs and things like that. So anytime you destroy a building as well, a bunch of little wizards will pop out and start attacking you as well. So that's always fun. And the little green circle means that they're in range to be eaten. But the eating thing doesn't work that well because the camera's movement is. I have to figure out how to get around the movement of the camera because it's not registering my click at the right spot. So if I click back a little bit, then it can work. But that's just a little issue. Anyway, I'll just real fast show you how the game is working while while it's playing. So I've got my dragon up at the top here, and it really doesn't matter in Z space where these things live. I just do this so it's a little easier to find them, and it makes a little more visual sense to me in the scene here in 3D view. Everything is determined by the depth or the order and layer. So, a lot of this stuff, like these trees down here, they look like they're flickering and they're popping, but in the game it looks fine because their depth are all different. Same with these houses here, like the buildings' depths will actually change depending on where they live in space on the screen. So, this was a kind of a tricky thing to figure out. But the way that certain objects can look in front of or behind other ones on a 2D sprite thing like this, because you can see, these are just flat. These are just flat pictures. So how do you make? And this is a flat picture. So how do you make this thing look like it's in front of this building when you want it to be, and behind the building when you want it to be? If it's just a flat image. So what I have to do is swap the depth. So if this is on a depth of 0, and this guy right next to it is on a depth of 1, then this guy's going to stand in front of the building. But if I start moving him up the scene, I'm going to want him to look like he's behind this building when we get around the back side of the building. So I need to swap his depth to like a -1. So the way I'm doing that is basically just by their current Z position, which it looks like a Y position in the game. I'm actually assigning a depth value based on that Z position. So when this object, when this little wizard guy crosses from back here to rather from up here to down here, his depth is actually changing from whatever this Y value is to whatever this Y value is, or Z value, excuse me. So he's going from depth of -50, -49, 48, 47, etc., to a depth of 0, and then to a depth of +1, +2, 3, 4, 5, etc. So he's actually going to be changing depths constantly, and they all are. Everything in the scene is, and that's how I'm going to be able to have certain things appear above other things and other things below other things, um, the way it should look. Now there are a few glitches with it right now, and you can see sometimes the guys actually like go behind things that they're not supposed to be able to go behind, and this is just a few issues, but that generally is how you would do it. Okay, so again, if I just hit play and then you guys can just watch up here in the scene view, you can kind of see the other little things that are going on. So I'm actually dropping down a oops. I am actually dropping down a new sprite for each one of these things, and it's just instantiating um, these. It's actually a sprite. It is a sprite. No, it's an object. So it's instantiating these objects and then placing them down here, and then that object has its own particles going on, and the particles are just this fire effect. So if I just simulate this, oh, it's not going to do it while the game is playing. But it's just shooting up fire particles of this funny little image that that I made of like just a very pixelated fire piece. And it's stacking up because I'm using an isometric camera, a 2D camera. So it's stacking up and making it just look like a hot core that's sort of like bubbling. I mean, it's not the greatest effect by any means, but it's something that gets the point across for the time being. I always plan to go back here. This is all temporary stuff. I just wanted to get some stuff on the page. So that's how that's working, and they're all shooting off of a little locator or a empty game object that I've got right at his head, and that's how they're actually shooting. That's where they're shooting from. I've also got these barriers in the scene, and these are just cubes that have their mesh render turned off, so they're invisible. And anytime it hits the barrier, the dragon's just going to turn around. The platform edges are the same kind of thing. It's like a little cage or a barrier pen for the wizards. So as soon as they hit one of those, which is actually a little far off, they'll turn around too. That was a bad example because that guy didn't. He just decided to ignore it. So again, this is not perfect, but it's working. It's sort of working. These colliders are here to interact with the fire. So, and you can see the ones in the center here are off. So anytime a building is fully destroyed, it just shuts its collider off, so it can't interact with it anymore. But you'll see up here, if I click on the houses and click on my dragon, so anytime this giant capsule collider interacts with these colliders down here, then that building would start doing its take damage routines and scripts, like generating particles and switching its sprite out for more damaged sprites and stuff like that. So that's pretty useful. These things up here, they're really simple. It's just a plane with a gradient mapped onto it. You can see right here. This is just the image, and they all have the same image on them, and I'm just tinting the images a little differently and dropping the alpha way down. So that's how we're getting that God ray effect, and they're just flat, parallel with everything else. Everything's flat in the scene. The only thing that really isn't super flat is the blood. But even that's just flat sprites that are moving around. So that's that stuff. The trees, nothing special here. I just got a few different tree sprites. Some are clusters, some cluster varieties, and the way I made all those was just painted one tree inside of Photoshop, and then duplicated a bunch of times and saved that out as like another image, and duplicated it in a different arrangement and saved that as another image. That way I'm not running so many individual tree instances over here. I'm just using little clusters and making it a little bit more efficient. The grass is just a plane with, it's a bunch of different tiles that I'm using to sort of piece together the ground. That's cool. I've made a mouse controls layer so that we can control this game via the mouse, because initially it was built only to work with touch devices. If you want it to work with touch devices, you can just toggle this one off and then go over here to touch controls and turn that one on. And then you have to change one thing on the dragon, which I can show you guys right now because I'm going to be providing all these source files so you can play with this scene. So if we go to the dragon sprite and go to the script dragon, if I click edit scripts, right here, you just need to convert this from touch controls to mouse controls. And I think there might have been something else. Yeah, okay, so unfortunately, it's a little more complicated, but not much. So you just need to take this touch controls, and anywhere you see the word mouse controls, you want to replace it with touch controls. So right here, these 4 lines, just replace that with touch controls, and you should be good to go. So that's how you switch it, and then it should work on an iPhone. I don't. It should work on an Android also. No, actually, it probably won't. It'll work on an iPhone if you're a developer and you want to compile this for iOS. And that's what I would recommend. In the meantime, though, we're going to switch it back to mouse-based controls because that's how most people are going to be playing with this game. Until I eventually turn it into a full-fledged game and then do some fun stuff and make it a real iPhone game. But I don't know if I'm ever going to get around to it. Changing gears so quickly, so often. But anyway, so that's that. Then we've got this enemy spawner. And it can spawn from these 3 different locations, which are just simple empty game objects. And inside of here, I've got an array. So if we crack open this script, can break it down a little bit. So I'm using what's known as pools to generate my my enemies on the screen. So there's 2 ways of, well, there's a bunch of ways, but there's 2 main ways that I know of that you can get something on the screen. So you can instantiate something like an enemy from the library, but it has to load it into memory at that moment. And that takes like a little bit of a hit, a performance hit. You may notice a little hiccup in your frame rate, just because it's throwing a new object into memory. So another way to do that is to create a pool, which is basically you instantiate a bunch of objects in the very beginning of the game, and that's what that loading time is. And then you just turn them on and off when you need them, and you have a pool of little guys that are already loaded into memory and ready to go. And you can just take one out and turn it on, and then it does its stuff. And then when it dies, you just turn it off and throw it back in that pool. So if you're gonna have a total of 100 enemies on the screen at any given time, you're gonna want to have a total pool count of 100 just to accommodate that. And you're probably gonna want maybe like 105 or 110 if you have 100. 100 guys, just so you have a little bit of an overlap, just in case. All right, so that's kind of how the pools work. So pools are best constructed with generic lists because they're very flexible, and you can have, it's like an array or like a group of objects. But with a generic list, you can add stuff and take stuff away from that list super easily, and you can resize that list really easily. Arrays don't really like to be resized, and you have to rebuild them, and it's kind of a pain. So I'm making a list of game objects, and that's what all this looks like. And so here I'm building the new list of game objects and putting in a total amount. So that's that 100 right here. So it's going to instantiate 100 enemies. And it's going to parent them into this group, this transform that has this make enemy script on it, this enemy spawner. And then it's going to set them all to be false. So their active state is false, which means that they're just turned off. And they're just going to pull them up. So you'll see if I hit play right now, you'll see a bunch of dudes pop up in here, 100 new enemies, and they're all going to be set to false, but a few of them are going to get built. See, now you can see them start to creep in. So new enemy 5, 6. You can see on the screen here that we now have 15 enemies on the screen. And as I need more enemies, I just turn them on from over here. And these enemies each have scripts that will activate as soon as they get enabled or they turn on, and then that'll start running their core mechanics and their really dumb AI. So that's how that works. And yeah, that's kind of it. And these God rays, nothing special. It's just some sprites, just some images, gradients. And the lights. So for these lights, I'm actually doing a bunch of point lights that all have like a certain range, and that range is determining how they, how wide of a cast they have. Again, nothing really too special there. I am using Toolkit 2D for this. for all the sprite generators or all the sprites. I know Unity 5 has got some really beautiful sprite tools now, and I just learned on Toolkit 2D, so I use it now for everything. But I'll switch over eventually because it's awesome. Yeah, so that. Oh yeah, so the units, their basic movement is pretty straightforward. I've got some particle systems here for their blood when they start getting attacked. They're based on colliders. So, when, or triggers rather. So when my dragon trigger interacts with its trigger, then the dragon trigger will tell it to do a bunch of stuff. And the dragon is just, again, another sprite. And here I've got some values that I can adjust to increase his speed. So when he boosts or when he does a little jump forward, like how fast it is and how long it is. And those are really just very simple little multipliers added on top of his normal speed. So yeah, you guys can play with all that fun stuff. On trigger, enter. Yeah, so when I hit a barrier, when I'm looking at the barrier tag, then and if it's the top barrier, then it reverses direction to 3, which is down. And that's all based on this mouse controls stuff. So if you click onto here, and it's the same exact thing as the touch controls, I just changed out the input method from input touch get key or get touch or whatever to input get mouse button down. Otherwise, these are the same thing, which is very helpful. So here, change direction. So I've got numbers for them: 1, 2, 3, and 4. 1 is to turn left. 2 is to turn right. And the reason I did it this way is because I wanted to limit the user from being able to go the opposite direction. So if he's moving to the right, I don't want him to be able to swipe to the left and all of a sudden be going left. I wanted him to only be able to swipe in 90-degree increments. So because I wanted to have a break and I wanted to have a boost, and I didn't want to have buttons on the screen for them. I wanted them to be based on the gesture controls. So that's kind of why I did it this way. By actually like limiting which directions it can change using this thing. So that's that. And I think that kind of wraps it up. If you guys want, I'm happy to do another like longer tutorial where I go in more depth into how I built this game. But the game is very temporary. It's just a placeholder. It's a prototype more than anything. So there's going to be some problems, going to be some glitches, things I still wanted to fix that maybe one day I'll get around to doing. But in the meantime, I hope this is helpful information. I hope it's useful so you guys can see how simple little iPhone and Android games are made. It's nothing special, it's just stacks of stuff stacked on top of stuff, and then it sort of does some stuff. It's very scientific. All right, guys. Well, thanks anyway. Thanks for coming around, and check out the other videos and the little game highlights for on my website. All right, thanks. Bye.